Earth, home of the brain.
If you think about it, pretty much all life on Earth begins with an egg. Even you and me. Once an egg grows into an embryo and starts its life cycle, the world opens wide with endless possibility.
Materials are special types of matter that can be used to make things. Builders, engineers, and the manufacturers of tools and utensils decide on which materials to use by carefully examining the physical properties of the materials. In this way, they know that they are making a tool that will do the job it was designed to do. Oh, there goes the oven alarm.
That smells good. Do you notice that I'm using oven gloves to handle the baking tin? This is because the material used to make the oven gloves does not allow the heat to be transferred from the hot baking tin to my hands.
This sort of material is called a thermal insulator.
Hey guys.
Hi Aaron. What are you doing up there?
Well, you guys wanted to set up an experiment similar to Galileo, didn't you?
That's right.
Come up the stairs. I'll show you the apparatus I've put together. See, I took 3 balls, all different colors and all different masses. So now we're going to throw them down at the same time.
You see, the purpose of this experiment is to see whether the mass of an object affects how fast it falls.
So, if you release the balls at exactly the same time and then measure the time it takes for the balls to reach the floor, that should answer a question.
That sounds right, but that means we'll need some more equipment.
Right. We will need a stopwatch and something that will release the balls at the same time.
All right, then don't forget pen and paper to write down all the information that you gather.
Okay guys, so while you decide the best way to collect the data, I'm just going to pop into the lab so you can find some more stuff to do experiment. Cool.
Right, to do the experiment, we'll need to record the results and put them in a table. Well, we'll need the mass of the balls and the time it takes the balls to reach the bottom.
That's a good idea.
Well, here we go. Look at this simple apparatus that we're going to use to release the balls exactly the same time from exactly the same height.
The balls are the same shape and size, but the blue ball has a mass of 300 grams, the red ball has a mass of 200 grams, and the yellow ball's mass is 100 grams.
I think we're all set. Okay. Will you record the times down there?
Sure, Aaron. Release the balls on 3. 1, 2, 3.
When a piece of sodium is placed in a trough of water at room temperature, you will observe that the sodium moves along the surface of the water quite quickly and melts into a little silver sphere. A gas given off from the sodium produces a popping sound as soon as a burning splint is brought near the metal in the water. When a piece of red litmus is dipped into the water, it turns blue, indicating that a basic solution has formed. From these results, we conclude that 2 products were formed during the reaction. Do you know what they are? Well, here is the chemical equation for this reaction. Have a look and compare your answer to mine. Sodium plus water react to form sodium hydroxide and hydrogen, or as a formula equation, Na plus H2O react to form NaOH plus H2. The balanced equation for this reaction will read 2Na plus 2H2O reacts to form 2NaOH plus H2. We have previously predicted that the reactivity of elements in group 1 increase from the top to the bottom of the group. Does this information help you to predict something about the vigor of the reaction of potassium and water that you are about to see? The piece of potassium reacts so fast that it explodes spontaneously and ignites with its characteristic lilac purple flame. The reaction is much more vigorous than either of the previous reactions, and a large amount of gas is released very quickly. A high-pitched popping sound can be heard as the potassium whizzes around the top of the water. Look at this. An empty 2-liter plastic bottle is filled with hydrogen and oxygen using a chemical process. The bottle is then placed on a flat surface, clear of obstruction on its side. Using a long splint, the gas at the mouth of the bottle is set alight. Why do you think the bottle took off like a rocket?
Everything we do in our daily lives involves chemical and energy changes. Lighting a candle, washing the dishes, starting a car, eating food, taking a pill to stop a headache, or baking a cake. Chemical changes occur through a process known as a chemical reaction. The substances that exist before the reaction are called the reactants. The substances that are produced during a chemical reaction are called the products. This is a model of hydrogen molecules and oxygen molecules. These molecules can break apart and recombine to form a new molecule, water. Here, hydrogen and oxygen are the reactants, and water is the product.
So, by 1805, Dalton's theory that elements were made up of solid, indivisible particles, or atoms, had been published. And by 1897, J.J. Thomson, after experimenting with Crookes tubes, discovered the electron. At this time, Thomson's plum pudding model became the ultimate way to represent the atom, an unchangeable solid ball with electrons sticking out of its outer surface. Then, about 100 years ago, a group of scientists, without knowing it, shifted science and the world into a whole new age.
Right, let's get started with the experiment. To begin our investigation, have a look at the apparatus I have here. I have a piece of copper wire that passes through a piece of stiff cardboard at right angles to the cardboard. These small plotting compasses can be placed on the cardboard around the copper conducting wire. Notice that I have placed the compasses in concentric circles. Next, I have connected the copper wire in series with a variable resistor to regulate the current passing through the conductor, an ammeter to measure the current, and a power supply.
Hi guys, here I have a nifty piece of equipment called a ripple tank. Basically, it is a shallow tank that is filled with water. It has a piece of wood that can bob up and down in the water, creating straight ripples. The motor is used to make the wood vibrate at a set frequency. Watch what happens when I turn the light and the motor on. There is light below the tank that shines through the water. Small ripples form on the surface of the water. Can you see the parallel light and dark sections on the screen?
To find out more about the photoelectric effect, let's visit Mr. Tony Voortveld, who has some very old scientific apparatus similar to the apparatus used to conduct the original experiments.
Well, in 1885, round about that period, a very interesting discovery was made by Heinrich Rudolf Hertz. the man who in fact proved the existence of radio waves. What he also did was he found an effect known as the photoelectric effect. And in our laboratory today, we can actually show a very simple experiment, a very classical experiment, if you like, on this particular effect. Here we have a typical gold leaf electroscope, and I'm sure most of you have seen gold leaf electroscopes in your time, but just to give a brief explanation, what happens is that if I charge the gold leaf electroscope with some electrical charge, a static charge, be it positive or negative, the gold leaf within the glass enclosure here will simply open up to indicate to us that such a charge exists.
People think I'm crazy, but I say I can be anything I want to be. See, ever since I was like a young kid, I just knew I wanted to be famous. Now all I gotta do is show the books who's boss, then nothing can stand in my way. Mindset Learned, home of the brain.
Let's see what happens if we reflect triangle GHP using HP as the mirror line or line of symmetry. Let's call this new point here I. Do you see the triangle IPH is an exact image of triangle GPH, and because they're exact images, these two triangles are congruent to each other. Now let's mark this triangle with all the markings from before. The angle here is 90 degrees. We know that this line is equal to this line, and we'll mark this like this. Now, this means that angle G is equal to angle I, so I can use the same marking. This angle at H is equal to this angle at H. This angle at P is equal to this angle at P. This side is equal to this side, and this squiggle is equal to that.
Hey, I have an idea. Would you like to go see a Cartesian plane? Wow, that sounds great. What do I need to do? Well, if you go sit in that aeroplane, then you will see. Cool. Right. Are you ready? Now put your feet up on the chair and close your eyes. Open your eyes. You are standing on the Cartesian plane.
It's huge and flat. It goes on forever. How do you find your way around here? You could really get lost.
Well, let's write your problem in a structured way so that we can explore it mathematically.
First, we're going to decide what things are going to limit your time. To start with, what time are you planning on getting up in the morning?
Well, usually I get up at 9 in the morning. But today I can wake up early, say about 7:30.
Fine, we can work with that. Now, how much time do you need to get washed and have breakfast?
I usually take about an hour or so. And me and my mother like to catch up over breakfast.
Great. The third thing we need to put down as a limit on your time is that at 11:30 you are going to watch a soccer game with your uncle.
Now let's stop there and think about the problem so far.
How much time do you have left in your morning for playing soccer and for homework?
Well, it looks like I'll have about 2 to 3 hours.
How did you come to that conclusion?
If I get up at 7:30, then I'll have time until the soccer game at 11:30. That's 4 hours. But I'll lose 1 hour for washing and breakfast. That leaves me with 3 hours. If I only get up at 9 o'clock, I would still need that hour for washing and breakfast. So I'll be left with an hour and a half.
Well done. Now, depending on whether you get up at 7:30 or 9 o'clock in the morning, you'll have between 1.5 to 3 hours for you to use. Is there anything else we need to consider?
So now let's work with a new transformation called a rotation. Let's start with a line and place a point in the middle of the line. That point is not allowed to move. We call this the center of rotation for the line. Now let's start to turn the line around that fixed point. If we create a new line for each rotation made, I will get something like the spokes of a bicycle wheel. It has a center that stays in the same place and spokes that turn around the center. We say that the spokes rotate around the center. Let's go back to the problem we started last time. The problem faced by mathematicians, how to determine the area under this curve, y equals x squared, between the x values of 0 and 1. If you remember, we said that there wasn't actually a formula that could be used, but that mathematicians get around this problem by approximating the area using shapes for which there is an area formula, namely rectangles. We explored two cases. First, we explored the case of tan rectangles. In this case, we divided the distance from x equals 0 to x equals 1 into tan equal segments. Onto each segment, we drew a rectangle like this and determined the area of each rectangle. Now, I want you to try and focus on something else. I'd like you to think about why the bicycle is going uphill or downhill in terms of what is happening to the function. In particular, what is happening to the function's value.
Okay, let's try that. It seems to me that the bicycle is going uphill because the graph is going up. The function value is increasing. Look.
Lesson 1 starts out by stating that calculus was invented to describe mathematically situations in the real world. It was invented as a tool for mathematical modeling. To give meaning to this statement, we introduce two such problems. The first deals with determining the area under a curve. This type of problem is solved by using one branch of calculus, integral calculus. Integral calculus deals with techniques for determining areas under curves and for calculating the volumes of solids.
The brain needs positive emotions to learn effectively: self-esteem, confidence, a sense of belonging, and freedom. If all these things are in place, learning can be totally exhilarating. Check it out on Mindset Learn, home of the brain.
Hi, I'm McFarlane Muleli and welcome to the exciting world of advertising. Most adverts are designed to encourage us to buy products or use services. They may also be shown to promote a company's image and the values that it stands for. Or they may be used to advertise an upcoming event. But not all adverts are about selling or promoting goods, services and events. Some adverts are designed with the intention of getting people to think about an important issue or support a worthy cause. Adverts like these are known as public service announcements, and they're the focus of today's lesson. By the end of this lesson, you should be able to distinguish public service announcements from other types of adverts, identify and explain the use of emotion, humor, and irony in advertising. Here's the definition of a public service announcement. A public service announcement is a type of advert that promotes a message of social importance. In other words, A public service announcement, or a PSA, is an advert that serves the public by making people aware of an important social issue.
Now, whether you use single or double inverted commas, they perform the same function. The function of inverted commas is to enclose the speaker's exact words. However, before you introduce the actual words of the speaker, you need an introductory clause to introduce the direct speech. What is an introductory clause? An introductory clause contains the speaker's name, an introductory verb, and a comma.
Now, let's think about scanning. Scanning is when you look through at something quickly to find a specific piece of information or to decide if something is relevant to your needs. In order to scan well, you will need to know what you're looking for. Can you guys think of when you would use a skill?
I know from last year you'd scan things like a television timetable or a phone book. You know, that kind of thing.
Yes, but you can also scan people or places. Like every time I arrive in a parking lot, I scan to see what cars are parked there.
That's right. We use scanning skills every day of our lives. In fact, Ntabi, you used your scanning skills when you got to the studio today. When you walked into this room, you scanned everything, didn't you?
Oh, I always do that. I like to look around where I'd sit and whether I wish to sit next to anyone in particular, so I have to look around as I come in.
So you see, scanning is a natural part of how we read the world. We can, however, practice our scanning skills so that we become more proficient at scanning and perhaps begin to find things that we might normally miss.
Let's start by looking at a 5-step plan you can try when approaching any Shakespearean play that you may be studying at school. Firstly, read a complete plot synopsis. Then, find an annotated copy of the work you need to study. Then it's time for step 3. Get comfortable and read through the play once. Let's move on to step 4. Watch a theatre production or video with your copy. And lastly, step 5. Read the play again and concentrate on identifying the themes. By now, you should have a good understanding of the key passages. At this stage, you should concentrate on the themes represented in the play.
Hello, Charlotte. I believe that you are about to interview Lady Macbeth.
Hi, Nellie, yes. We're here at a theatre where in a few moments we will be meeting up with the infamous Lady Macbeth. Lady Macbeth, you have been described as one of Shakespeare's most famous and frightening female characters. Why?
I disturb people. From the moment they meet me, they realize that I am ruthless and more ambitious than my husband. I will stop at nothing to get what I want.
How do you plan to make Macbeth king?
The only way is to kill the king, to kill Duncan. And how fortunate for me to receive a message that he's on his way to spend the night here.
And how do you plan to kill him?
Macbeth will do it. He will take a knife and when Duncan is asleep, sneak into his room and stab him until he's dead.
But will Macbeth do it though? Will he be able to kill his king?
I would make him do it. He has never said no to me.
Books are like magic. Like a door you pass through to find yourself in a whole new world.
Now I'm going to unplug everything and let's work together to connect all the external components to the correct ports. First, we must connect the keyboard and the mouse. But how do we know which cable plugs into which port? Well, some computers have made it easy and put a little symbol or icon under each port. This tells you if the port is for a mouse, a monitor, or a keyboard. But even if there are no markings, you can still tell which cable goes where just by looking at the connector at the end of the cable. For example, look at this connector for the mouse. It has 6 pins and a plastic plug in the middle. This connector will only fit into one kind of port, like this. The same goes for the keyboard cable. This printer cable has a connector called a USB connector. It only fits into a USB port like this. When you're buying external devices, it's very important to check that the new device will be able to connect to your computer. Not all computers have the same kinds of ports, and if you buy a device that does not fit into the back of your computer, then you won't be able to connect them together. Online chat rooms are a great way to meet new people and share ideas, but they can also be dangerous and can be used by criminals. Just listen to this true story about what happened to a young girl who was playing on her mother's computer at work and entered a chat room.
About a year ago, Lisa and her friends were playing on the computer and decided to go onto a chat room site on the internet. They'd never done this before and thought it would be fun. Soon they started chatting to a boy. He said he was 15 and seemed nice, so they would chat to him for about half an hour each day. After a week, he asked if they wanted to meet him. They said yes, as it would be nice to meet their new friend, but nobody had told them about the dangers of chat rooms. Luckily, they decided to go together. He gave them an address of where to meet him, as well as his cell phone number, so they could call him when they arrived. In return, they gave him one of their cell phone numbers. On the arranged day, they went to the meeting place and only saw 2 men in their 40s standing outside. They looked like they were waiting for someone, but there was no 15-year-old boy around. They decided to call the cell phone number they were given. That's when one of the men answered his phone, and they knew straight away that these men were pretending to be their 15-year-old friend. Luckily, they turned around and went home. One of the guys kept phoning for a couple of days, then he stopped. Luckily, they hadn't given him their home addresses. As you can see from what happened to Lisa and her friends, you should never give out any personal information about yourself in chat rooms. And definitely do not arrange to meet anyone, because you just don't know who you've been talking to.
Well, I think it's time to leave you guys on your own. I'm out of here. I'll see you later.
Well, let's get started.
Hey, somebody's broken the CPU.
No, man, don't worry. Gamers take this off all the time so that they can add in their own cooling components. Remember how I told you how much they love to overclock their processors? All we have to do is put it back on. Then use a special substance called thermal paste. This helps to conduct the heat away from the CPU onto the heatsink, and then the fan blows the heat away.
Oh, but why does one of these corners look a bit different?
This CPU is square. Now, as each CPU fits into the socket in a particular way, this notch tells us which way it must go in. You also get CPUs that come on cards, and we call the place that they connect to a slot, like a PCI slot holds a card. So does that mean that wireless network is very different from what we've learned so far?
Not really. There are a number of similarities between all networks, which we have discussed before. Now, can you identify the components of an Ethernet network you will find in a wireless network?
I guess that in a wireless network, we still have devices at nodes, and each of the devices has a network card. But will we still need a switching hub or a cable?
Well done, Morwa. Now there's another device that can be found in both Ethernet cable and wireless networks, and that is a router.
Hey, that looks just like a switching hub.
Well, you're right, Zamor. Nowadays, it's very difficult to tell just by looking at them. But this router has a very, very special function. Now, the router allows computers in different types of networks to connect to one another, to a printer, as well as connecting the network to the internet. So, as the name suggests, the router tells the signals which route to take between the connected devices. So the router is actually directing traffic between the connected devices.
Sometimes spelling and grammar can really pay off. Mindset Learn, home of the brain. Mindset Learn, home of the brain.